I'm Justine Murphy, Senior Editor at Laser Focus World. Thanks for joining us for this quick chat, part of Laser Focus World's PhotonicsNXT. Right now, I'm talking with Sanjay Gangadhara, Chief Technology Officer at Zemax. Welcome, Sanjay. It's great to be talking with you.
You too as well. Thank you, Justine.
All right, well, let's get into product and system manufacturing. How are optics and photonics playing a role in that?
Thanks for that question. It's a really interesting time where I've seen that optics and photonics have become an essential part of the manufacturing process. I kind of see this playing out in three different areas. Certainly, I think this is true for industrial manufacturing, and I'll talk a little bit more about that. But also, I think it's true just across the board, across a variety of industries and applications. Whether that's in life sciences, consumer electronics, or automotive. Coming back to industrial manufacturing, I think one of the key areas that we've all seen a growth in, especially around the areas of optics and photonics, is laser manufacturing and the use of high-powered lasers, which are becoming standard for cutting and welding complex components. This is true, I think, because these laser systems offer the companies and the engineers who are working with them higher accuracy and higher precision when you compare how they can cut and weld components compared to traditional methods for doing that. It's interesting because I've also been seeing just a lot more about the use of lasers in industrial manufacturing in other areas as well. Read an interesting blog the other day about the use of lasers actually for rust removal from industrial components. So as a safer means for preparing those components for manufacturing compared to, I should say, some of the chemical treatments that these components often go through. For some time now, lasers have also actually been used as a part of industrial manufacturing for marking components. So for actually, in the automotive industry, this is actually pretty common, where lasers are used to actually tag components, and again can be much more accurate, much more precise for marking those components relative to traditional stamping or etching technology. So just in a variety of applications, really lasers are playing a key role in manufacturing. I think the other area where optics is playing a role really in manufacturing is as a part of the manufacturing process itself. So as you get into these highly complex manufacturing floors, where you're looking at product fabrication and assembly, machine vision systems that have highly precise cameras that are being used to do inspection and validation of the manufacturing and assembly process are becoming critical. And if you Google the term machine vision, you'll just see it becoming ubiquitous throughout a variety of applications, but especially within industrial manufacturing. Now, a lot of these systems are of course taking advantage of kind of smart onboard algorithms, whether those are based on machine learning or other tools to be able to make decisions about what's going on during the process. But those algorithms are really being driven by the images that are coming in to feed them. And those images require, high quality images that require high quality camera sensors on board these systems. Another area in terms of manufacturing on the factory floor, it's not just the inspection that machine vision systems can offer, but actually the assistance that tools like automated robots or cobots, which is becoming a popular term for collaborative robots, the tools that they can offer in assisting with manufacturing tasks. And so you're seeing robots start to play a larger role in the manufacturing process. I think this was true or has been growing true over the last several years, but it's a trend that just has been accelerated by the pandemic, where you're trying to minimize the number of human interactions in the floor and see how much you can leverage machines as a part of that process. And again, these robots, in order to function accurately, reliably, are going to rely on high precision, high accuracy cameras and optical systems as a part of that. And then finally, this isn't really necessarily about manufacturing itself, but I think we'd be remiss if we don't address the fact that a lot of products and systems themselves are containing optical components. So if you think about anything from smartphones to automotive heads-up displays or mixed reality goggles, all the rest, I mean, these all these are all systems that are being manufactured that contain optics themselves. And so the ability to accurately fabricate and manufacture the optics, of course, is important as a part of the manufacturing of these products themselves.
Okay. Well, how has that optics and photonics role evolved as systems are getting smaller in size?
Yeah, no, I think that's a great question as well, Justine. I see the growing role of optics and photonics in manufacturing really having gone hand in hand with system miniaturization. I think the use of lasers in manufacturing is a good example that illustrates that. I mean, again, we talked about high-powered laser systems being more prevalent in manufacturing for cutting and welding. And that becomes even more important as the things that you're trying to cut or weld become smaller and smaller. And you really need that higher accuracy and the smaller footprint that a high-performance laser can offer. Right? Lasers also offer avenues to technologies, beyond just cutting and welding, things like additive manufacturing and 3D printing. These are technologies where components can be built up layer by layer to any size. And again, these are technologies where we're often targeting small miniature components to be able to have that fine level control to be in their manufacture and production. And again, a critical area for lasers to contribute. We're seeing that 3D printing and plastic molds as well are playing an increasingly important part of manufacturing the optical components that are that are a part of these systems. And these technologies are playing that role because, again, these optics themselves are also getting smaller. So it's, of course, as the systems themselves are getting smaller, the optics that may be embedded in those systems, of course, also have to get smaller. And so you have to use technologies like 3D printing, plastic molding to be able to make such systems. Doing so can be very challenging, right? Making these kinds of very small level optics, very small level systems can be quite challenging to produce. And that's where, again, using high precision camera sensors to identify small defects or problems that are occurring during the manufacturing process can just be critical to be able to assess that you're getting the right performance and the right yield out of these systems.
And so you mentioned the challenges that are present for that manufacturing smaller products. What role does simulation play in addressing those challenges?
Well, I think, as someone who is the CTO of a simulation company, of course, I feel like simulation plays a strong role in product design and development more generally. But as we get to smaller and smaller devices, I think that role just becomes even more amplified. And one area where I think about that is that as products themselves are getting smaller and smaller, they're going to experience, in many cases, larger amounts of stress and strain during the manufacturing process. You're really putting a lot more load and a lot more tension on the parts as you're trying to manufacture them, when you're trying to manufacture them within tighter mechanical or physical restraints or constraints. In addition, products that are smaller, because they're smaller, their performance is really heavily being driven by their size, and so they can tolerate smaller variations in their shape or size. You can't have as many manufacturing errors in the manufacturing process that are introduced because their performance will degrade much more significantly at that smaller size. And the latter is really especially true for optical components, because even generally as mechanical components are getting smaller, they need to fit within tighter tolerances. Optics themselves already fit within tighter tolerances. With a mechanical system, tolerances might be in the order of microns, and that seems pretty reasonable to a mechanical engineer. For an optical engineer, a tolerance of microns may be well unacceptable, and we may need an order of magnitude or 2 orders of magnitude better performance. And so this really puts a lot of significant burden on the manufacturing process to get it right the first time, right? You don't want to be wasting a lot of production time, throwing away a lot of yield as a part of this process. And I think simulation is critical to that being successful, right? Because with simulation, engineers can understand the impact of manufacturing errors, and they can mitigate them in the design and fabrication process the first time.
Okay.
I did want to point out that, for optical products, we are also finding that simulation tools are providing new insights into the impact of structural and thermal effects on product performance. And this is enabling engineers to account for these effects as a part the design and manufacturing process. And so I'm excited that, and many of your viewers here may have already heard about this, but at Zemax, we're launching a new module that we're calling our STAR module for doing structural thermal analysis of optical systems that allow for stop analysis. And I think this is going to be a really exciting tool in the simulation tool belt to help users in the design and manufacture of these smaller optical systems.
Okay. Well, on behalf of Laser Focus World, I'd like to thank our guest, Sanjay Gangadhara of Zemax, for joining us and offering some expert insight into the evolution of the manufacturing industry and the increasingly important role of optics and photonics in this space.
Well, thank you, Justine.